I can convert, add, and subtract with units of time, so we haven't seen time, but also we should be able to convert between Fahrenheit and Celsius. Now, the Fahrenheit and Celsius thing especially, you'll have the formulas for that, both on the exam and if you wanted to, write them down real quick so that you have them on the side, so when you do the assignment, that's perfectly understandable because you'll be able to use those on the exam as well. So there's no need to memorize them. Some people find it fun to memorize, and if that's fine, if you do that, that's fine, of course. But there's no requirement here that you need to memorize those formulas. Now, these time conversions are conversions which we expect you to know. I don't remember if they actually give these to you on an exam, except maybe this one right here, okay? Now, the reason why they have to do this, 1 year is 365 days, is because we're pretty much throwing out leap years for these. So you don't have to be like, well, what about the fourth year? Oh, okay, we don't want to overcomplicate this. We just want to know that we can convert between different forms of time, okay? So again, it is expected that you know that 1 week is 7 days, that 24 hours is 1 day, that 60 minutes is 1 hour, and that 60 seconds is 1 minute. Those are expected that you know those already. So convert 4 days to seconds. I am still going to use dimensional analysis here, although plenty of students look at this and they're like, hey, you know what? I know I can do this with straight multiplication, and that's fine, okay? But I'm going to use dimensional analysis. So I would look first at my conversion factors here. Okay, so we're trying to go from days to seconds. So we'll start with days, right? Because that's actually what we are starting with, is 4 days. Down here I see days here and here. We got 1 day is 24 hours, and then 1 week is 7 days. We're not trying to go upwards here or make this a bigger unit of time like a week or a year. So these two are out of the question. What I notice then is that there is not a day to second conversion factor, which means I'm going to have to take the days and convert them into hours, the hours then into minutes, and then the minutes into seconds. I'm looking at 3-dimensional analysis here in order to change these 4 days into seconds. And I expect them to be a lot of seconds because there's a lot of seconds in a day. So, yeah, no problem though. So we can take those 4 days and with dimensional analysis, we'd put it over 1. Okay, so we're going to multiply this by another fraction. I want to eliminate the days. So with days in the numerator of that first fraction, I need days in the denominator of the second one so that they will cancel out. My conversion factor down here says that these days will now change into hours. And it is 24 hours for 1 day. I know I put days there. It doesn't really matter because the days, of course, will cancel. But if I put this into the calculator, this will tell me how many hours 4 days is. So 24 times 4 in my calculator, and it says now instead of 4 days, you now have 96 hours. All right, that's pretty good. But we don't want hours. What we would like is seconds. So we're going to work our way into the smaller units of next. It will be from hours to minutes. So I'm going to make that 96 hours, again, over 1. We're going to multiply this by a conversion factor, which is something divided by itself in order to create a 1. This time, though, we want the hours to cancel out, and those hours should change to minutes. So it's 60 minutes for 1 hour. And when we multiply this out, the hours will cancel out, and we will be left with minutes. So in my calculator, I got 96 times 60, enter, and that's 5,760 minutes. Okay, now we're almost there, right? We're really enjoying ourselves. And so we're going to finish this off by taking those minutes. And the last thing we're going to do is convert those minutes into seconds using that conversion factor of 1 minute is 60 seconds. I'm going to make that over 1. We're going to make this fraction. Once again, I want the minutes to cancel out. So I've got minutes on the top of the first fraction, and then I've got in the bottom of the second one, and that will then change the second fraction with seconds in the numerator there. Okay? 60 seconds for 1 minute there. And now the minutes will, in fact, cancel away, which is what we want. And we will be left with some number of seconds, quite a few of them, actually. So in my calculator, 5,760 times the 60. Notice, again, I'm going back here, but remember, I'm not multiplying the ones because I know 1 times 1 is 1 in the denominator, and that will not actually change my overall answer. But this is the answer that I get right here, 345,600 seconds.
Wow.
And that's it. Now that's 4 days, right? So is that a lot of seconds? You get to decide. I mean, yeah, if you look at it all at once, perhaps it is, but you know, once you get old like I am, I guess it's not so bad. Now going back as well to other lessons that we've had, the dimensional analysis on this part, it may be obvious, right? Some of you may have seen, well, to go from days, there is no days to seconds conversion factor here. So you may have noticed that you need to work your way down into this conversion factor, or I guess up in the list. But that may take some time until you get used to this stuff. Hopefully you have, you know, with the experience that we've gone over in this unit, that you feel pretty comfortable doing that. But again, the dimensional analysis may take the most amount of time. Okay, let's do this one. Take 7 minutes, 33 seconds, and change this into just seconds. See if you can do that. Take a minute, do it, then we'll go over it. So let's take that, we already have seconds right here, the 33 seconds. We'll keep those in mind. I'll try not to forget to add those in. But I'm going to look at those 7 minutes, and let's just change those into seconds. Okay, so of course there's a minutes to seconds conversion factor here. We're going to make that 7 minutes over 1. We're going to multiply that by a fraction, which is something divided by itself, or 1. And so yeah, that's going to make us put minutes in the denominator, which means we'll need the seconds in the numerator. Okay, so it says that it's 60 seconds for 1 minute in the conversion factor, so the minutes will in fact cancel away. And when we multiply these, now we will have only the seconds. So that's just the 7 minutes though, which is now going to show 420 seconds. But then we had the other 33 seconds that we now need to add in. So we're going to take those 33 seconds and add them in, and this will tell us how many total seconds there are. So that would be 453 seconds. That's it. So yeah, those 33 seconds, they are seconds, so of course we would need to add those in at the very end. Okay, try this one. Convert 4 hours, 10 minutes to hours only this time. So last one, we went from a big unit and worked our way into smaller units. Mixed, of course. Now we have mixed units, but we're going from smaller units into bigger units. Try this one out, then we'll go over it. So on this one, it says we're converting this into hours. So the hours that we start with, 4 hours, is how many whole hours we have. So we're going to have 4 and a decimal, some number decimal hours here. That decimal is going to come from the 10 minutes. These 10 minutes right here, okay? That is what's going to fill in this decimal value for us. So all I've got to do is change these minutes into hours, and then I will have the decimal, which I will then add into the 4 hours right there that I've already put in there. So, excuse me, we got those 10 minutes. So let's take 10 minutes and convert these. I'm going to use dimensional analysis into hours. So this will, let's see, this conversion factor, 1 hour is 60 minutes. So we want minutes to cancel away. So I need 1 in the top, 1 in the bottom, as I have here. And this will convert then into hours. So 1 hour is 60 minutes, according to that conversion factor. When I use this, the minutes will cancel away, and I will just be left with hours. Yeah, so, well, here's the thing is, multiplying the numerator, right? We've got 10 times 1, which is 10. Now, I'm using the denominator here because it's not just 1 times 1, it's now 1 times 60. So I've got 60. Now, in my calculator, I would type this in as 10 divided by 60. And I would get the decimal, 0. It's going to show, again, this is how many hours just the 10 minutes is. It doesn't include the 4 hours. But my calculator, it showed me 0.166, and then there's just a bunch of sixes there, okay? So that's 6 repeats. It does say to round to the nearest hundredth. So if that's the case, then I would look to the tenths, hundredths there. 1 to the right is that 6. So I would need to add 1 to the 6 in the hundredths place value and make this 0.17. So where I have the decimal set up, I already know there's 4 hours, but then I also have an additional 0.17 hours. And now we have converted our answer, or the 4 hours, 10 minutes into hours. But really, it was only just the 10 minutes that I had to convert into hours, because those 10 minutes are the only partial hours that we have. We have 4 full hours, so we fill that in, and then once we get the partial number of hours from the 10 minutes, then we fill that second part in. So I kind of look at it as two separate problems, even though the first one we could say is just kind of copying it down. The second part, though, is where that conversion factor comes in. You and a pal went to the movies together, but watched different movies that started at the same time. Your movie was 4 hours, 12 minutes long. Your pal's movie was 3 hours, 29 minutes long. I don't think they make movies this long anymore, but whatever. How long did your pal have to wait for your movie to end? It's kind of like it's asking how much longer is your movie, or how much earlier did your pal's movie get out, end, whatever, okay? Which is why this ends up being a subtraction problem for us. So we will expect subtraction to be used.
So you said there's no negative, so we have to do it like,
What we're going to do is we're going to take your movie, which is the longer one. That's at 4 hours, 12 minutes. And we will subtract. I'm going to do the 2 units separately. We're going to subtract your pal's movie, which was 3 hours, 29 minutes.
43.
That's correct. So, if you were to do this, of course, we see the minutes, which is where we should start, right? We should always start with the smallest units, just like we would with regular subtraction, which are base 10, where we start with the ones place value, or any decimal furthest to the right place value. This time, though, we start with the smallest units, the minutes. Of course, 12 minutes minus 29 is going to put us in the negative. We shouldn't have negative minutes. What even would that represent? We don't know. I don't know either. So that means I'm going to take 1 hour away from the 4 hours. I'm going to take one of the hours away, minus 1 hour. And the 12 minutes then allows me to add 60 minutes in there. Right now, those 60 minutes are from the 1 hour, just like we've seen before. But now the conversion is with time. So we've done this with feet. Seems like, I don't think we did any meters. They were all U.S. customary units, but now time. So this is going to change that top value. It's your movie. It's still the same number of minutes total, but I'm showing it differently now as 3 hours, 4 minus 1 hour. And then 12 plus 60 would be the 72 minutes. Okay, and then from there, we're still going to subtract the 3 hours and 29 minutes from your pal's movie. So this is going to leave us with some number of minutes. If you needed the conversion factors there, they're gone now. But now we have, what was that, 43 minutes? Thank you. And, of course, 0 hours. Now, I'm putting the 0 hours in there because on the assignment, they may have 2 boxes for you to fill in, and you'll need to fill in the 0 there. Otherwise, they'll mark it wrong.
This one done?
Okay, so this one, again, we're adding units of time. Now, this one's hours and minutes. Just be prepared on the assignment, of course. They may do like minutes and seconds. So this one, we will probably see some carrying. Just expect the carrying to be maybe a little bit different on the assignment depending on what units they use, okay? But try this one. Take a minute, try it out, then we'll go over it. Okay, well, I'm going to do the same thing. This one, of course, is just telling us to add. So we got the 8 hours, 25 minutes. We're going to add the 2 hours, 40 minutes like this. And again, I like to do this 1 unit at a time, starting with the smallest units. Because again, by adding, if we make enough minutes to make an extra hour, which we will, right? 60 minutes will make 1 hour. So if we get more than 60 minutes, we'll have to convert one of those or 60 of those minutes into an hour. So by adding these, of course, we'll have the minutes first. 25 plus 40 is 65 minutes. 8 hours plus 2 hours is 10 hours. Now, this answer is correct, right? 10 hours, 65 minutes is okay. It's just not simplified, which is why if you were to type this into the assignment, it's still going to mark it wrong. It's not false. You haven't done anything wrong. It's just not simplified. And by simplified, we mean, like what I was saying, you got to take those 60 minutes, 60 of these minutes, and convert that into 1 hour. So I'm going to show this. I'm going to take away those 60 minutes, which then allows me to add 1 extra hour. Okay, this is, again, is the same idea where it's not going to change the overall value, but it is going to change the way that it looks. So now I have 11 hours, and then the 65 minus 60 is 5 minutes. Boom, that's it. Now, of course, if, let's say that there were still more than 60 minutes here, I would have to convert those into hours as well. You know, it depends on how many minutes they give us up here. I don't see them doing that, but just if they do, know that you may have to take more than 1 hour at a time, depending on how many minutes they give you. Now we've got our variables. So we talked about this during the objective, is converting from Fahrenheit to Celsius will require variables, meaning the temperature, of course, varies, which you probably notice since it's pretty hot out there. It's July. But it varies, right? Even between night and day, it varies. So it changes. That's what we mean by varies. And so as a Fahrenheit may change, so will the Celsius change, as long as they're equal. And then as Celsius changes, depending on where you are in the world, of course, a Fahrenheit would also change in order to match that, which is why we have formulas. Now, with variables, we usually use X. We're not using X so much today, but in writing with variables in math sentences, we generally avoid the letters O, I, L, lowercase, and then lowercase e as well. And there's reasons for that, but we'll save that for a different time. Yes, sometimes they represent many values, which is why they call them variables. So using and defining variables is a key feature in problem solving, which is what we're going to see with these formulas. That's it. Now, the good news is they're going to give us the formulas. There's only 2 variables. You got Celsius and Fahrenheit for both. And if they give you Celsius and say convert to Fahrenheit, Celsius is kind of our variable. Fahrenheit is what we would call our output, or our outcome, or your dependent variable. I'm getting real nerdy there. Oh, and then if you're trying to make Celsius, then it's the other way around. So evaluating algebraic expressions as well. Again, they're going to give us a formula with variables, and then we plug the variables in depending on which one they give us, and then out comes a different value, which is what we would call the simplified form, or the evaluation of that formula. So we have seen formulas before. We've seen them with fractions. I don't know if we saw so many with decimals, but we did see a lot with the whole numbers and integers as well. So technically, most of this is supposed to be review, not necessarily new stuff. Okay. In fact, I think we've seen either the Celsius formula or Fahrenheit formula on in the fractions unit, because they have fractions. But again, they gave you the formula then. Now they're giving us the formula again. This would be Fahrenheit to Celsius. How do I know that? Because it equals Celsius. There's nothing happening to the Celsius. I put in the Fahrenheit, out comes the Celsius by itself. Okay, but I'm doing stuff to the Fahrenheit in order to get that Celsius to come out. So down here, they say, look at your Fahrenheit degrees is 59 degrees. Sorry, that degrees is kind of offset. Okay, so I take this formula. Let's just copy and paste it, because that's really all we're doing overall. And again, my Fahrenheit degrees, which is F in this formula, I am now going to put in 59. Okay, so the 59 goes where the F was, 59 degrees Fahrenheit, which is the reading on some temperature, thermometer, whatever. Now, this is something that I just type into the calculator. Okay, now this is plenty of work, what I'm showing right there. I replaced the F with 59, but I'm going to type this into the calculator. So I'm going to do 5/9, and I'm going to do that as a fraction with my N/D button. I'm going to push the open parentheses button just above 8, and then I type 59 minus 32, close parentheses, and on my calculator, it looks exactly like the formula that I have there. Just, I don't want the equal C part, right? So I push enter on my calculator, and the calculator says, oh, that would be, now it's 15 degrees. I do a better 5 than that. 15 degrees Celsius. Boom, we did it. Now, if you wanted to show more work, show your order of operations, you could do the subtraction and then multiplication, you can. But since we're able to use calculators right now, this is plenty of work right there. So, of course, now that we've done Fahrenheit to Celsius, this one will change Celsius to Fahrenheit. Again, how do I know that? Because it equals Fahrenheit all by itself. I put in Celsius, out comes Fahrenheit. So try this one out. Using the formula, convert 17 degrees Celsius into degrees Fahrenheit. 30 seconds. Okay, well, let's take a look how we got that then. So Fahrenheit, again, this is my formula. So notice there's just a lot of copying and pasting right here, which is also why they call this plug and chug. So we're just plugging in a value, like in this case, Celsius, where I'm gonna replace the C. But that C is Celsius degrees, and this will change to Fahrenheit. So the C, wherever it was, I just replaced that with 17. Now, I'm putting that 17 in parentheses. You could do 9/5 times 17, but once again, when I put this into the calculator, I can make it look exactly like this part right here. Okay, so I type in 9/5, and I'm using the N over D button there. I get out of that fraction. I type open parentheses 17, close parentheses, plus 32. And yes, my calculator gave me the same thing you got. And again, this is in degrees Celsius, so don't forget to label this either. But that came out as 62.6 degrees Fahrenheit. And that's it. Okay, and that does it. So again, we did some conversion with time units, units of time, and then addition and subtraction, but also a little bit of this temperature stuff with Fahrenheit and Celsius. Once again, though, you do not have to memorize those formulas. They will be given to you. So even if you felt like you needed to look them up, you can, or just refer back to this video. That's good too.